pieces of metal, layout and fit, and your references. There is a short section in your textbook on page 4-80 to 81 that talks about joggles. And then in AC 4313 is kind of the whole section that talks about forming metals, where we pull out different little tidbits. So here is what you do need to know about the purpose of a joggle. There you go. It's to allow clearance for a sheet or an extrusion. So a joggle is used when you need to step up aluminum to another surface so that you maintain a smooth surface at a joint or a splice. And these are used at the intersection of stringers and formers. Also for antenna doublers, so whatever it is that you start cases class, communication, instrumentation, all that, you talk about antennas, and then you go look at antennas, be on the lookout for joggles. So this, we have our antenna on top of the airplane, and then we have our skin, but we need to be able to attach that antenna firmly according to specs. So you need something called a doubler, which we're going to talk about towards the end of this class, to rivet that antenna to, or whatever fasteners are used to attach it. So underneath of the skin, we have our doubler to give strength for attaching points of the antenna. But because now we're inside of the airplane, we've got stringers, and this would be like running lengthwise, running, and the specs would call for this doubler to be attached to the next supporting structure. Here we just have a nice L joint, and we could throw a rivet right in there, rivets down there. But over here, it would just butt up against it, but we need it to actually overlap. But we can't just put this whole thing on angle, so it has to lay flush, and then step up and lay flush again. So this lecture is talking how do you make that step up appropriate. Did you ever think there might be a lot of details in aviation? One whole lecture on one little step up. It's very fun and exciting. Yeah.
Without going into too much detail, why do you have to do that? What's the purpose?
So for right here, if we just ran this like a butt joint, just like right up against that, the specs would require this doubler to be attached, physically riveted to this. So we can't just attach this to the skin piece. It has to be attached to the stringer. So to get it to go up onto that stringer, you have to, whatever thickness that is, step up onto that. So going back to talking about metals, remember from materials and processes, and we talked about properties of metals, what happens when we start to bend metal? I heard, yeah. Work hardening.
Like the inside of the bin will get more compressed than the outside will stretch.
Excellent. We're compressing in here, stretching out here. What are some others? I heard some rumbling.
Crack.
It may crack. By the way, it's super tempting when you have a great big old sheet of metal to walk around and go wang, 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 and it's very fun. But what are you doing to it? You're work hardening it, so don't be doing that. Don't be doing it. I know it's tempting. And I do it with the scrap piece, which is so fun. But don't do that with a brand new metal. Because then, when you go to rivet it and drill it, you're going to start having issues. So, properties of metal something where you, I should have grabbed a scrap piece of metal, but you can use your imagination, where you bend it and you're like, oh, that wasn't right, so you bend it back. And now I try to do it again. Every time you do that, you're work hardening it and changing that structure and making it more prone to cracking. So, you gotta do the math, figure out what kind of bend you want, figure out your equipment, put it in the break, and then, oh, look at this, I just need a little break. Woo-hoo. Ka-chunk, right to the bend that you want. So you gotta do a lot of planning, preparation, so it's not just trial and error. There will be some trial and error, we're gonna talk about that, but eliminate that as much as you can.
Does that happen just with bending, or does it happen with flexing too?
Also with flexing, yeah.
Because like airplanes flex, so it's like power and
Right.
work hardening it, but we
Yeah.
don't
And
necessarily have to replace a working part in a certain amount of time.
correct. So there is a certain amount of flexing that is planned for and allowed. I think you go through that in flight controls maybe, where, and I think I do later on in this class too, like show you the videos of like big airliners, like they are flexing, I forget how many feet at the tips of the wings. But that is all engineered, planned for, and they know how many cycles of that, because I mean it's happening super quick. Like how many hours, thousands of hours, that airframe structure can handle that, because it is work hardening it. And at a certain length, they're like, okay, this aircraft needs to go out of service. Also, the longer an aircraft is in service, there's more inspections that have to be done, or the inspection has to be done at more frequent intervals. So yeah, that is all considered. Thank you. Alright, so what do you think, going back to when we talked about grain structure a little bit in corrosion class, it can be hard to tell in some metals, but we have grain structure this way, grain structure that way. How do you think you should have the grain structure aligned compared to the way you bend it? Yeah. So bend lines need to be perpendicular to the grain of the metal. So if you have metal like my fingers, you want to bend it like that. If you bend it like this, then that grain is going to start to separate as you pull it around the bend. So, perpendicular, not in line, otherwise you're going to get cracking.
How can we tell what the grain direction is?
You can look. Like you can kind of look at a piece. Now, the smaller they get, it's harder to tell. And sometimes you're making multiple bends and you have to bend it. But then you go back to, actually not back to, because we're going to be talking about that. You make more gradual bends or a larger radius, so it's not as tight of a bend.
Would it be better? Okay. I'll talk to you later. Nitpicky.
Is there a question over here? So, when you can tell how the grain structure lays, and when you have the option, make sure bend lines are perpendicular. Otherwise, you'll get cracks, like they're trying to show there. Here, oh, there it is. This, we've got cracks happening in here. This is also something to tuck away in your hat when you're inspecting things, to look on outside of bends for cracks to see if that's starting to form. And then if you get cracks, we said like that.
What if all your pieces that you're using for the project have the grain going the 6-inch way instead of 3-inch way? You're going to have to do it parallel, right?
Right. Many, often you don't even have the choice. But if you're able to, and you can tell the grain direction, then do it perpendicular, because that's best. You can do it the other way, you just my joggle, now I would have a longer piece of metal to make the joggle. But step it up onto there from this surface up onto this surface. That depth here, it makes sense. You have to know the thickness of the material you're stepping onto. Because that's the total reason you're making that joggle. And this length, which is represented with W, so the length of the joggled portion where it's not flat, is you start with a calculation 4 times the thickness of the metal you're stepping up onto. So that's a key calculation you'll need to know. 4 times the thickness of the metal. And then, just like in riveting, we always like to give ourselves extra space, extra wiggle room. So generally speaking, you'll add a 1/16 inch to that 4 times thickness to allow for extra clearance. This is a really good method to start out. I want to see you all do that calculation when you get to that point in your riveting project. 4 times the thickness, add a 16th. But we're going to talk about, okay, what actually works in the real world. But make sure you write that down for now. Yeah.
4 times the thickness of just the piece you joggle, making a joggle.
That you're going up onto. Yep. And on the right side, whenever you place, so here's our joggle going up onto our piece of metal. So you take this piece, 4 times that thickness, add a 16th, and that is what this length should be. When you place it onto the piece you're joggling onto, make sure you have plenty of clearance. That's what we're adding the 16th for. You don't want to just jam it in there, because what would happen right at that point? It's going to wear, stress, concentration, cause cracks. So not that. We want that. That's a good one. Grant.
The W measurement.
Yeah.
It's a little detail, but it changes how you do it. Are you measuring the length that angled section travels, or the length of that angled section? It's sort of like, are you measuring straight down, or measuring like from the angle to actually
right.
get?
So,
You see what I mean?
yeah, so the way you guys are going to do this, you're going to have a flat piece of material, and this calculation, we're going to talk about how you put rivets onto it. But you'll do the start of your bend, because you would want a row of rivets in here, wherever that starts. And then on your flat piece, measure 4 times the thickness and add 1/16, make another mark, and those are your bend lines.
Okay.
Does that answer your question?
Yeah, it answers how I do it.
Yeah.
But like, if you would ask me, what's the length? Am I measuring it from straight
Right.
down or from the angle?
So I believe this is measuring straight down rather than like from that point angled up to that point.
Okay. Yep, that makes sense.
Yeah. Because, yeah, you'd have a little bit of geometry change. Yeah.
Okay. Yep.
Yeah.
Thanks.
Yeah. Other questions? Now, here's a little tricky thing. Give me a definition of tolerance and allowance. Anyone? Kiki.
Allowance is the plus minus, say, 0.025. Tolerance is would be 0.050.
Yeah. So if I have this stick, and it has to have a 1-inch diameter, but it can be 0.25 larger or 0.25 smaller, my allowance is plus 0.25 and 12.16.25 under joggling, kind of in the middle of that first paragraph, it says this. Allowance is the distance between the two bends of the joggle. That's not what allowance is, but, because they're saying it's like from here to there.
That's one of the opposite, right?
Right. It's like taking the dimension and then going, yeah, it's just,
Why did this shoot?
I do not know, but it's there. You may see that. Whatever that dimension is, so that, I would like this to be the dimension of the joggle. Like, just say that. Don't try to name it an allowance. But the dimension that the joggle should be, so what should it be? What is a little formula that you should do?
4 times the thickness,
Plus,
160.
so it should be from this line to the next line we're gonna joggle should be 4 times the thickness of the sheet you're jogging me up onto plus 160. Now, most of the time that is going to be specified in the maintenance manual. You don't even have to do that math. They would just tell you, right here. Oh, that's a sight line, 0.125. But you can figure it out from your aircraft drawing what that should be. Because we have, yeah. So you'll be able to figure out what that dimension should be. So I just mentioned another word, which is sight line. So when you figure out your rivet pattern and then your edge spacing, I had this tidbit on another slide coming up. Wherever your bend line starts, that is considered an edge for rivet spacing. So, and I'll have it on slide, you'll be able to see it later. But, so you would measure your edge spacing from the bend line here, edge spacing there, measure out your 4 times the thickness plus 1/16, bring it to your break, but as you take your piece, I'll recreate my break here, and slide it under the nose of the break, and then your bending lead is gonna put a nice bend into it. What do you think the problem is? Because the nose of the brake actually comes out a little bit. I make my nice perfect line where I want the exact bend to start. Slide it underneath. Now what's my problem?
Can't see the line?
Can't see the line. But you don't have to cry because you can make a sight line. So if you know the bend radius, so let's say we want a 0.25 bend radius, or no, yeah, 1/8 bend radius. That's a good one. 1/8 bend radius, and we have radius bars you can put under the nose of your brake to give you that good radius. We're going to talk about that more after Christmas. But if you mark 1 bend radius from the bend tangent line, I'm throwing a lot of terms at you today. Don't worry, we're going to really work out definitions when we talk about this channel, because that's a lot more exact dimensions we're looking for after Christmas. So this is just to kind of introduce you to these terms. So bend tangent line is where your bend is actually happening under the nose of the brake. If you mark a line that is 1 bend radius away from the bend tangent line, that will be a sight line that you can see. You place your sight line right where you can see it. So you slide it in under the brake and just put your eyeball above it. Make sure you can just see the sight line, and that will place your bend line at the correct position in the nose of the brake. This is something I'm telling you as much as I can, but really until you go and do it, it might be kind of muddly in your brain. But you do need to know sight line, mark one bend radius from the bend tangent line, and then make sure you put your eyeballs directly above the nose of the brake. So here's our brake. Here, keep your eyeballs in your head though. Here's your piece of sheet metal. Here's the bending leaf that's going to bend that up around the nose of the brake that clamps that piece of metal down. Okay. Questions on that? Anyone disturbed by the eyeball? Questions? Okay. Now that I've thrown all that at you, hold it, let it kind of settle down. You don't have to think about it over Christmas. Just let it settle down. We're going to come back to that after Christmas because I don't expect you to have figure out a precise bend radius when you do your joggle because it's so tight and so tiny. Normally you'd be joggling up onto a thicker piece. So tight and so tiny it'd be very frustrating. So I'm not going to expect that for the joggle. I will be expecting it for the U channel, but we're going to talk about that after Christmas. So here is that slide I was talking about. When you're riveting or laying out your rivets, where the joggle bend stops, that is considered an edge for the rivet. So when you do that piece, measure off your rivet line first from your actual edge. So you'll do 2D here. Yeah, these are universal heads. And then make sure you do 2D to your first line. While that metal is still flat, you'll measure then, what will you measure to make your joggle section? 4 times the thickness of what you're going up onto plus 1/16. Now, when you place it under the brake, give yourself, make sure you can see that line, or else whichever way make sure you give yourself a little wiggle room on this side, so that you're not bending too close to that line. And you're going to do, I'll do practice pieces with anyone that desires that, or make sure you for sure do practice pieces by yourself before you do it on your actual piece. We've got tons of little scrap pieces. Practice to your heart's content.
The edge distance has to be from both of those lines. So what if it's smaller? You have to make sure it's at least that big.
It has to be at least 2D,
At least.
and you can.
Does it get bigger?
Now you still have to. I want this to not be more than 40 for this project. But yeah, if you scoot it out a little greater than 2D, that's great. I'll give yourself more wiggle room.
Just 2D from either.
Yes. Yeah. So how do you go about actually forming a joggle? Talk about 2 methods. The first one, we don't have the equipment here. The second one, we do. But you need to be aware of how to create a joggle with forming blocks and dies. First of all, they'll ask you questions on it. Second of all, if you love sheet metal and you go somewhere that has an amazing sheet metal shop, you'll be using this stuff. So you do need to be aware of it. So you can create a joggle with forming blocks or really fancy dies. That's how manufacturers do it. They have a really fancy, expensive equipment. This does have to be used for curved pieces because it can be curved that way, like a complex curve. But what we're going to use is our cornice brake. This one also, whenever you go into the sheet metal shop, the giant brake find out which one you like. The cornice break is a method we will use, and that's easy to use for a piece that's flat this way. So we're just bending, my notes are gonna get all crumpled. But we're just bending it like that. Some pieces would have a curve that way as well. So that would be a compound curve, like, yeah. It's kind of rough showing it to you on paper, but just to, yeah, get the idea that some are bent that way and that way. So compound curves like that, you have to use special dies. You can't use a cornice break.
It's just like stamping it.
Yes, it is. Yeah. So what they want you to know, and they will ask you if you are using forming blocks and dies, they can be made out of hardwood or steel or aluminum. So wood obviously is easiest to work with to make the die. So if you just have like one unusual piece that you need a forming block for, just make it out of wood. That wood is going to start to crumble pretty quickly. Probably can't make more than one or two pieces, but if you're only planning to make one piece, much more, yeah, much better with your time to just whip it out of wood. If you want to manufacture several pieces, or maybe like, oh, I'm going to start an assembly line of airplanes, and now I need to make 100 of these pieces, then you need steel and aluminum to make your forming blocks. Aluminum is preferred because it is easier to work with than steel, and it does the job well. It also, if it gets a little dinged up, it's easy to polish it, much easier than steel to polish it out. Oh, then yeah, I have fancy CNC machine things that can just form it. If you do wood blocks, you just make the blocks into the form you want, place the metal in there, place the blocks in there, put it in a vise, crank it down. If it's a compound curve, you may have to take the metal out, flip it around, tap down any bulges with a wooden or rawhide mallet. But we're going to talk about that forming metal also after Christmas. Yeah.
You use wood as a juggle. There's got to be some limit where the material that you're bending is just too thin.
Yes. 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 For sure. And here is a fun little free fact. You can make your own out of aluminum, your own forming die. If you have to bend something that already has an angle in it, like this guy here, we want to bend those edges. Just take a piece of aluminum, make a slot 4 times the thickness of the material you need to step up onto, crank that into a vise, squish it down, maybe tap it out with a mallet. So that's just a pretty fun fact if you ever find yourself in a situation. Question? We are not going to worry about making forms. We'll just use our lovely cornice break. And you do need to be familiar with the parts of a break. We got the work table, so that's where you kind of lay your piece on, slide it in. The clamping bar with the nose of the break, which then your bending lead, you'll bend that up and around to get your bend. Also be aware whenever you are bending your sheet metal up, aluminum is going to have spring back. So if I wanted this to be like a 45-degree angle, I bend it up. As it comes up, as I release the bending leaf, it's going to spring back a little bit. So that's something you can practice with. doing it a little beyond 45, see where it comes. So you just tweak it a little bit at a time, a little bit more, as long as you're doing little amounts and not cranking it to 90 and like, oh, that doesn't work. Crank it back down, crank it up again. It ain't gonna start working hardening. But if you just whoop up, oh, a little more, whoop up a little more, so you're good. Yeah.
With blue light fittings, it's supposed to line up directly to the spot that we're putting it in.
Yes.
My question is, can what we're doing with sheet metal be under some sort of tension, or does it also have to line up perfectly?
So it's not as critical as fluid lines, but it depends on where it's going. And you want it to line up as close as possible, otherwise, yeah, you don't want to put more tension on those rivets
Right.
than necessary.
I'm just thinking with that, like, bending farther than we need to go, that's gonna be kind of a guessing game.
It is.
So
It is.
if it's,
Yep.
and I don't wanna harden it, I think I'd rather have it slightly off than go back to hit that again.
Well, correct. Yes.
Okay.
As long as you're not, yeah, just, you're gonna work with it, you're gonna get a feel for it.
Yeah.
So I say, yeah, go out there and work with it, because you'll probably be surprised how quickly you get very accurate.
Okay.
And you do want to be as accurate as possible. You don't want to rely on the rivets to bring in your piece further.
Yeah.
All right, time for a break before we talk about how to put the piece in the break. Come back at 12:30. Just let that honey up.
Go ahead, do that. As you have.
Finish all of the ice.
What were you guys laughing about? Nothing. Nothing.
I love that. Hey, Christina. What is our quiz on
I think we
today?
gotta turn the school on unhinged.
We don't have anything for the midterm.
I was under the impression we had a quiz on the drag.
I know what it is. I know. I'm like, 'cause somebody else asked me about a quiz. What is it? Quiz? I think it was in my schedule.
Okay.
What? It is, I'm doing a listening guide style. So, throughout one of my classes, instead of like a quiz, they do a listening guide. So it's a quiz grade, but it is open during lecture. So it's like you listen, you fill it in, I give you the answers more as a,
Okay, so it's special fast days.
yes.
That's
Thursday.
Thursday.
It doesn't,
But it's just open during lecture.
That's really good. That makes my week a little bit easier.
Open book, open during yeah.
Nice, okay.
Yes.
And then what is midterm prep where?
With a little bit of drag. Any written questions? Bullets are still like or multiple choice.
All prep, all.
Thank you.
Yeah, that is a really good act.
I know.
Sweet.
Hey Graham,
What's up?
sorry, this is completely off topic. Did you finish all the lab school, testing? I have a question about, so on lab, 3, pneumatic and electrical de-ice boots. Yep. Question 5, it asks, sorry. It asks,
That question, dude.
which of the items is collision reflecting the de-ice boots? Regular intervals.
Yeah.
You found that in the manual, right?
Yeah.
I'm not, I can't find that anywhere. And so I'm wondering if,
Even though the manual says something different than that.
What does the manual say?
I can't see anything about regular intervals, that's the problem.
Okay. Does it say anything about a liquid being put on boots?
service, or, servicing for the boots.
Yeah.
Cause it said cleaning and
I
servicing.
got quite a few wrong because I was not looking at both. You really have to look at both. Both are sometimes.
Cause I figured it'd be in the servicing section.
Yeah, there's servicing and the actual section that talks about like the operation of the boots, and then there's a separate section about servicing of the boots. So it's like three sections that I'm looking at, and I did not realize that till too late. So,
We should not very much.
yeah, you're good, dude.
I appreciate it a lot.
That is manuals are not fun.
No,
Dude, use the card. I cannot imagine doing that and not realize that.
it's hard because, well, he can like look by chapter and stuff.
Yeah.
And it'll give a little description. I can't do that. I have to look for numbers.
Get on the card.
Is it easier?
It's so much easier.
I see you guys using it, but I haven't.
So after class,
Yeah.
I think when we head out there, you think you could just give me a quick rundown of doing the flush head movements, like how to.
Oh, yeah.
I think it's you drill first and then the dump, but I just need to.
Correct. Oh, yeah, I'll do that too.
Okay, awesome. Thank
You
you.
might have to remind me, but.
I will.
I feel like I have to. Thanks, man.
yeah, for sure. So you just yeah. There's no section. Dude, it sounds like a concert. No, you don't have to be. Or Hella Blues. You ever played Hella Blues? Nope. That game is terrifying. Where you going? Get back over here. Yes. Hang up. Hella Blues. I just think they use your phone. My mind went to there we go. That's how it is. Across little switch on like every 2 hours. It's also very that way if you have
Yeah, right.
stuff in your okay. So it's open comms all the time. Trucking through the plant. And you can just hear like a burp and then there's like windows and metal hitting all the way. Yeah, no, it's terrifying. But it's also like actually worse. So like this massive. So you got I think it's like World War I think it's the Civil War. But yeah, it's a realistic gun that you never know. There's no blood or anything. Just the gun. It's just that's terrifying. They still don't kill you, so you never know if you kill them. Oh, that's you, Dad? I mean, we should play a game. I think this is one of the
That's relatable.
I threw my fairy dust out.
Thanks, Linda got that.
Did your fairy dust make people fly?
Apparently not. I wish.
I was so
The eyebrows is when you, yeah, same. Yeah, he'll show you.
Alright, let's get started. Let's see, who's missing? We got there, we got there, we got there. I don't care if you stand up as long as you let things behind you see.
Can't see.
Okay. The people, if anybody's not back, let's see.
Looks like pizza tonight.
What is it? I'm gonna tell you a little secret tidbit for those of you that have arrived. So here is the joggle piece on your riveting project. Hey, what's special about those rivets? These ones. They are A rivets because they have plain heads. So make sure you're attaching your joggler piece with plain head, soft aluminum type A rivets. Now, here, as I turn this over, you can see that joggle, and you can observe that joggle while I take second question.
Right.
Did you have a question?
Yeah.
Yeah.
It's just for those A rivets, we'll have to turn down our
Rivet
rivet
gun.
guns.
Yep. Yes, you will. Or, what is another method of riveting we talked about that might be a really good idea? Yeah, you can squeeze them. So that'd be a really good road practice using the squeezer dog. You don't have to. You can use your rivet gun, but yes, if you use your rivet gun, make sure you turn it way down low. Do a couple practice rivets in another piece. So this joggle, when the piece is flat, how are you going to measure the distance from bend to bend? Yes. So the next part we're going to talk about is how bendy do you make the bend? This is where trial and error does come into play for joggle and why you need to practice on scrap metal first with the same thickness, because thickness of this does make a difference too. Because if you make a super tight bend, like the bend radius in here, which you don't really want to, then it's going to be taller, whereas if you make large gradual bends, then this whole thing will be a little more shallow. And you'll see that as you do practice. The way that I'm going to grade these is, obviously I'll be looking on the back that your edge distance is good here, but also the bend here is a proper edge distance from your rivets. And you can have it greater, a little bit greater than 2D. Definitely not more than 4D. But to give yourself a little wiggle room. Well, the way I'm going to grade this, because this should be a nice, pretty flush surface, I'm going to take my straight edge and lay it up here. Well, I can't hold it and point all at the same time. I'm going to lay it up here on the joggle piece, and then, now this is a sheet that came from an old manual that Dwayne had. I have copies of this. So when you get to the point of making your joggle, if you forget how to position the material, you can see me and I'll give you a copy of this, physical paper copy. But you'll put your piece into the break, bend it up. Now, this paper, it had, I forget, it was a different angle than 45, so I wrote that on top of there. But you bend it up about to a 45-degree angle. Works pretty good for the joggle we need to do. Then, so you put it in, bend it up, then you're gonna take it out, flip it around, so it's bent. Take it out, flip it around, and then you're going to bring the bending leaf up just until this is in line with that. They're both perpendicular, parallel. They're both parallel with each other, that and that. So this is just an eyeball. You come over the edge of the break, please, oh, one more, whoop, oh, there we go. You have to make noises too. And then pull it out, you should have a nice joggle. I have a video of a fellow doing it. I don't know what language it is. And so if you know the language, I hope he's not saying anything bad. It doesn't seem like he is. But his methods are really great. So we will come over here. And he shows some other stuff first. We'll come right about. Okay. I'll try to now.
On a utilisé l'utilisation de la plieur. Premier ajustement. Attention. C'est correct, on peut en ajouter un peu plus. Vérifier si on est au bon endroit. Oui. Maintenant, on le relève. On a gardé un pouce, on le lève, environ 75 degrés. Voilà. Deuxième étape, on va le redresser très peu afin d'avoir un joggle de 25 millièmes seulement. Il faut laisser très peu d'espace entre les deux. Parallèle.
So this bending leaf of the brake, that is why you need to use either the blue cornice brake or the giant brake by the wall, because our other brakes do not have enough space on here to give you leverage to bend this part back up. The others, that's too narrow, you can't, yeah, it won't grab that to bend it back up. So that's why.
Comme ça, je le descends, je le tombe et je remonte celui-ci un peu. Bon, maintenant on va vérifier notre produit fini. On a un bon 25 millième et plus. On devrait être suffisant avec.
Questions on there?
Avec ça.
Anybody know what that language is? It is French. That's what I thought it was. Oh, did you?
What a beautiful joggle.
That's great. I should have turned it up so you could tell me what he's saying. So some of you are not going to get the joggle until after Christmas. Totally fine. You're gonna have time that week after, but I want to talk about it for anyone who gets to that point. Really make sure you're following the directions of your lab to put all the pieces in order. Very important. What is the purpose of a joggle? Give me the sign. Oh. Very good. Yep. Allow clearance for a sheet or an extrusion. So you should now know the purpose. Remember grain structure, how to plan it out, how to form it. The end of that lecture. However, we're going to do a little bit, just a little review, start review for the midterm. A couple people asked me about the quiz. And I was like, quiz? No quiz? And then somebody else asked me about the quiz. There's no quiz. And it finally dawned on me, ding, I can get access to my super top secret schedule. And in the schedule was the word quiz. Which is why I don't give you access to my super top secret schedule, because then you panic about things you don't even need to panic about. So I'll tell you now, so you don't have to panic. So tomorrow, let's see, tomorrow's Wednesday. I'll probably start the special fasteners lecture tomorrow. I might break it up between tomorrow and Thursday. And there is a quiz on special fasteners, but because I'm slamming information at you, and some of this information is like many steps ahead of where you might be at, and I like to try to quiz you on things that you are doing, because I don't know, that's how I learn better, if I hear it and then actually do it, and then I can answer questions better on it. So, yes, there is a quiz. You're going to enter questions into a document that is giving you a quiz grade, but I am going to open that and turn it into a listening guide, which means it is open during my lecture, and as I go through the PowerPoints like I do, I'll say, this is important to know, or by the way, did everybody get that question? So, if you fail that quiz, you are just completely not listening at all. So we will work through it together. You'll have it open during lecture. If you prefer to just take notes during lecture and do the quiz later off your notes, totally fine. I'll leave it open like probably, tomorrow through Friday. You can, and I think it's all multiple. Don't quote me on that. Might not all be. But yeah, we'll work through it together so that you can listen, be typing in or typing in, clicking in. So that you can then use that listening guide as a study guide, and then there'll be a lab on it too. But so yeah, there will be a quiz grade, but open book during lecture. How much better can it be? Like, no quiz at all. Okay. I'm gonna pull names for a little bit. And the first one using, most common ones. 2117. Where would you go to find that information? Very good. Yeah. Is it a sport?
Where you juggle while jogging.
That's hilarious. I didn't know that was a good. I would fail some of this. Oh, okay. Tiki. The general rule for finding proper rivet diameter is, actually, hold on. We're going to do a group vote since everybody's talking. So Tiki, you get off on this one. General rule for finding proper rivet diameter. Which one of those? Correct. 3 times the thickness of the thick sheet. Very good. Mark. Okay. Tiki, I'll give you this one. Since they're quiet again. The shop head of a rivet should be, ideally, which one of those do they think is best?
Just asking for diameter. Oh, it says diameter in all the questions. It helps if I can read. So that'd be 1 and 1/2.
Correct.
The diameter of the rivet.
Correct. 1.5 times the diameter of the rivet shank. What, for anyone, what should about the height of the shop head be? Yep. Half. And Shane, what is the purpose of a gusset or a gusset plate used in the construction and repair aircraft structures?
We'll go with Charlie.
Charlie! Are you sure about that?
I'm sure, yes.
It is. To join and reinforce intersecting structural members. Alright, David. Select the alternative which best describes the function of the flute section of a twist drill. Excellent. Forms the cutting edges of the drill point. Alright, this is for anyone. Which one best describes the function of the violin section? Sorry. It's too close to Christmas. I can't help myself. Okay. We're going to do everyone on this one.
We went over this.
How many MS-20 470 AD 4-6 rivets will be required to attach a 10 by 5 inch plate using a single row of rivets, minimum edge distance, and 4D spacing? Okay, what's your answer? Alright. Bunch of people have been memorizing prep work, which is good. It's good because you do have to do that. However, make sure you know how to do this problem because on the actual written, they can switch things up. They might switch that up, they might switch that up, so make sure you're able to do the math so quickly. Someone, or not quickly, whatever time it takes. What are some methods to do this problem, or what are some critical things to remember about doing the problem? Yeah.
We're not upsizing, right?
Correct. So prepware, you do not upsize because they think you're absolutely perfect. Actually, they don't. They think they're perfect. Anyway. So yeah, you would use an exact 4/32 rivet. Not sizing up. What are some other things?
You could find it for 15 inches and then multiply that by 2.
between rivets be? What would that decimal be? 0.5, yep. So that's our spacing. What is our total distance around the plate? 30. It is 20, if you do the math. So if you divide 28 by 0.5. If you forget, you can see me and I'll work with you through that. Okay.
What was the answer?
56. But yeah, I'll gladly, if you're like, I can't figure out how to do that, I'll gladly go over it with you. Oh. Jimmy. On a semi-monocoque fuselage, the skin is reinforced by longitudinal structural members called what? Excellent. Furrow, longerons, and stringers. And Randall, what is a minimum edge distance for aircraft rivets? Done. Diameter of the rivet shank. Excellent. And Joel, what is the minimum spacing for a single row of aircraft rivets? 3 times the diameter of the rivet. Bargain. Alright. And Jedediah. Refer figure 1. Which of the rivets shown will accurately fit the conical depression made by a 100-degree countersink? Excellent. Numero uno. Any questions on that one? Corbin.
Yes.
Which is correct concerning the use of a file?
I'll say alpha.
You're right. Apply pressure, forward stroke only. Unless you're filing very soft metal, light aluminum, so your pieces can go back and forth.
So, a
Yeah.
single cut file is gonna give me a smoother finish?
Second.
A smoother, why not be?
Oh, why not B? Because, actually, so we talked about this. Anyone remember why not B? Yeah.
Double cut is just, double the number of, origins on the file, so you can
Yes.
remove more material.
So it's kind of crisscrosses each other. Yep, yep. Following that, so that's not the answer totally yet. Do you remember what double cut, what second cut was? Let me see.
I thought second cut didn't mean anything.
So I think it was double cut wasn't anything. One of them. Anyway, you have coarseness of files. So
Okay.
so you can have a smoother finish maintained by double cut. You can have coarse double cut, a much finer single cut. So that just double cut versus single cut does not guarantee
Right.
you smooth. It has to be a more fine
Yeah.
or a more coarse. Yeah.
So if, that might be, but if I have the same coarseness file and the same, like, same file, one's double cut, one's one's double cut, one's single cut. I thought since, like, if I think of sandpaper, if there's more
Right.
per inch, then it's gonna be a smoother finish.
I don't. You should test it out.
Okay.
Yeah.
I mean, either way, it's not the correct answer for this. So
It's
it doesn't matter,
removing
but-
more at a time.
Yeah, okay. Yeah.
Yeah.
Yeah, his theory does make sense, actually.
you don't get a what?
My bad.
Yes. Sorry, you weren't here for that lecture. Oh, he gets a free pass. Okay. Israel. Which procedure is correct when using a reamer to finish a drilled hole to the correct size? Excellent. Turn the reamer only in the cutting drill. And Carter. Clad aluminum alloys are used in aircraft because I like that confidence. Yes. Surface layers of pure aluminum or aluminum alloy bonded to core material to inhibit corrosion. And Kurt, which statement is true regarding a cantilever wing? Excellent. Bravo. Those are the ones, no external bracing, they had no external struts. Alright, we are going to stop there for today. And with your lab, okay. Everybody has signed off the 3 pieces. Give yourself a hand. Well done, well done. And almost, I only have 1, 2, 3, 4, only 5 people still needing to do their practice row. So, well done. Round of applause. So keep doing what you're doing, getting your new pieces. As you gather your brand new pieces, Tuesday, yeah, just keep working on the 25 thousandths and the 32 thousandths. And then rivet those. So make your pieces, rivet those. When you're rivet. When you get to where you need the 40 thousandths, then you can acquire and dimension your 40 thousandths piece. We're going to hold off. There are some, you look so sad. There are some smaller 40 thousandths on the cart next to the table where I kind of station it in the sheet metal shop. So if you're getting close to that, you may grab one of those pieces. But we're going to hold off on pulling out the giant brand new 40 thousandths till maybe later this week, just so stuff doesn't get mixed up. So here is what I'm trying to do. And now that I'll share it with you, you can all help me. So I am trying, and it started out really good. Randall did the 25 thousandths down at the far end of the sheet metal shop. So we're going to keep 25 thousandths down at the far end. And then I forget who cut the 32, was it you guys? And they did that at the other end, which was perfect. I didn't even plan it, just kind of happened that way. It's perfect. So we're going to keep it 25 and 32, opposite ends of the shop. The 32 is living on the table where I have my things. So on that table, keep only brand new, workable 32 thousandths. Any scrap pieces that you get that you cut too small, which you would need to see me about those anyway. Any scrap pieces, there's a cart, I think it's towards the far end, a rolly cart. That's where all scrap pieces go. Don't just chuck the scrap into the throwaway cardboard box, because unless it's like really tiny, if it's at all rivetable for practice rivets, save it on the scrap cart. So 25 stays down at the far end, 32 near on my table, and then on the cart that's by my table, that's where I'm putting the workable couple of 40 thousandths that we have. Questions on that? So with you all helping to keep things neat and tidy and placed where they belong, it'll help everyone's sanity. Also, whenever you pick up a brand new piece of aluminum, take your calipers and just double check it. Double check your caliper to make sure it is what you want. So 25 should be 25, 32. You do need to peel back the blue protective, just a hair, just enough to get the tips of your caliper onto that metal to measure it, because you don't want to measure that or else you'll think it's too big. So, always measure before you just cut it, and especially before you dimension it and rivet it, and then you're like, oh, I just put a 32 where 25 goes. I'll be like, did you measure it? Okay. So, yeah, working through. The wings are still available. Any questions? Going, and to the lab. Randomly. Yes.
So, 0.042,
Yes.
0.032,
Yes.
0.045.
Yes.
For the stuff on there, the sections on that part.
Right.
If I printed out like just a piece of paper that said that, and just put them on those tables, would that be helpful?
I think that would. Thank you.
I finished the first set. I don't believe it's for,
My car, I do. But, oh, I do have a reverse people.
Wait, is that Apple? At my mom's house.
alright, just finished all of our ice and rain control.
Yeah.
Bro.
Are you done with it?
Okay, cool. Thank you. Yeah.
So now I'm just gonna go over Christina's stuff.
Question, statement? I
And
was
I'm done
visiting
with
the
fuel systems
three
too.
rows. That went a lot better.
That's great.
And I revisited that one row, but it went pretty bad again. I was confused. It's the same size rivet, and so I'm like, I don't know what I keep slipping and making smile. And I don't think I made a single. I have to look. I made almost no smiley smile. Is it? I'm like wondering how to secure it. And then also, when you do have a long thing, how are you like securing it to rivet it?
Yes.
Because you can't do it this way anymore.
Right.
So can I borrow your,
So I've done.
caliper
I
again?
did these. These were.
Yeah.
Thanks.
Oh, and that's good. Mine's not perfectly flush. I
I'm
was
trying
really
to
struggling.
stop.
I think my issue is this piece is like extra curved, and so I was
That
really
makes
struggling
sense.
with. And then the back of it, it was just like this is not work as nice as me. So that was my issue.
Yes.
I wondered if you had any suggestions.
I'll come take a look at how you put it into the vise.
But for the next ones, are we putting it vertically in the vise and or
You can, like, I mean, you can kind of flip it however
yeah.
works. But if you want, like, you can put it that way, do those rivets, flip it around. Yeah,
Okay.
yeah. However you find works best.
if I had, I think, maybe I could get these two then?
Oh, yeah.
Would that
Be
be
very
it
good.
on the case?
Yes. Yes, it would.
I don't really understand the joggles.
I think once you
we
get
get
there
there,
and
yeah.
you play with it, like just grabbing scrap pieces and going ka-choink, ka-choink. Oh.
And does it matter if which side the shop head's on? Is it usually like the joggles are down?
Yes.
Or is it not? It's not
Usually it goes under.
underneath
Yeah.
the other? Okay, so
Yeah.
okay. Well, good start. Yeah. These are pretty easy, so I probably won't have questions. Well, not easy, but it's similar to this, just a different style.
Right.
Which is nice.
Yeah.